Lesson 08 is area. Area is the surface covered by a figure. It is the product of usually two dimensions, like length and width or base and height, but it's always the product of two dimensions, and that is why it is always labeled square units, because it is inches times inches, which would be inches squared, or feet times feet, which would be feet squared. Area is always in terms of square units, and you label by putting the unit to the second power, like this, or you write square inches, square meters, whatever, and you could say SQM. Now, here's the thing that I want to make sure nobody ever does. So let's say you've calculated an area and it was 20. Never, ever put 20 squared meters. That is completely wrong. If you're going to use the exponent, it goes on the unit, not on the number. Okay, so please do not get that confused. Now, just like I said yesterday, these formulas that I'm going over, you need to just commit to memory. 8th grade standards require that you have to know these on your own. They're not going to be given to you. So you need to know that the area of a rectangle is length times width. The area of a parallelogram is base times height. I want to point out what they usually do with parallelogram. It's kind of tricky. They give you this base, they give you this height, which is a perpendicular distance to the base, but a lot of times they'll go ahead and give you this number out here too, just to confuse you. So in a parallelogram, you got to remember it's a rectangle that's pushed over. So you need to look for this right here. That right angle means that this is the actual height of the parallelogram, and that's the distance that you use. It's base times height. It's base times height, not length times width on a parallelogram. It makes a difference. All right, a square, since all the sides are the same, technically it's length times width, but since the sides are the same, it's really side squared. So side times itself. So those are the basic shapes, rectangle, parallelogram, square. Now let me move on to a triangle. Knowing that there are 3 types of triangles, I want to mention each type so that you understand. The formula doesn't change, but the shape changes. The formula for area of a triangle is 1/2 base times height, or a lot of people like to say base times height divided by 2, same thing. One or the other. So you got to realize though there are 3 different types of triangles. So when the triangle is a right triangle, the 2 sides that make up the right angle are the base and height. Those 2 legs are the 2 that you use for base and height. If it's an acute triangle, okay, so it's acute, the base is outside, but the height is going to be inside, drawn to it. And again, you look for that right angle because that means that that's a perpendicular distance. It's called an altitude. You need that. That tells really how tall it is. So you use the base or a side on the outside of the triangle, and the height will be inside if it's acute. And then obtuse is really the weirdest one, because you use one of the sides, the base, and then the height is really going to be outside the shape. You're still looking always for that right angle, and that determines the height. So the height, it's sort of like this one. It's from the opposite vertex, a perpendicular drawn to the base. Well, that's true, but there's no way that you could drop a perpendicular from this point up here and hit that side of the base. So they draw this thing out here called an auxiliary line. the dashed line, it's like imaginary, it's really not there. And you drop that height down to it. That's the distance that you would use then. So 3 different triangles, they all use the same formula. You just have to be aware of what 2 sides are the base and height. It depends on what kind of triangle it is. All right, a circle, you always use the radius. You know how on circumference yesterday, if they gave you the diameter, then you just say, okay, I'll use pi times diameter. Or if they gave you the radius, you say, okay, I'll use 2 pi r. Well, with circle, this is the one and only formula. It's pi times radius squared. So that means if they do give you the diameter, you need to divide it by 2 to get the radius. Now, one thing that I want to point out about this, you make sure you always square the radius first. You always square the radius first. You know, PEMDAS, exponents come before multiplication, right? So you got to square the radius first before you multiply. Do not go, oh, I'll take 3.14 times that 5 radius and get an answer and then square it. No, your answer will be entirely too big. So do your exponent first, then multiply by pi. Okay, and then the last formula that you are expected to know is a trapezoid. And, you know, the trapezoid, it kind of comes, it's derived from the triangle formula. If you could picture it maybe being a portion, if I connected these, that you kind of think, oh, well, that would make a triangle. So it's the formula is kind of derived from that. So you end up with the trapezoid having 2 bases. It's the 2 sides that are parallel. Those are your 2 bases, and notice, see that right angle? That distance between them, you got to have it at a right angle somewhere, whether it's inside or outside. That's the height. That's how far apart the bases are. So if you think of this as 1/2 base times height, like a triangle, you're kind of right, except there's 2 bases. So here in parentheses, you've got to add those 2 bases together to get 1 base value before you multiply by height and then 1/2 of that. So trapezoid is 1/2 times height, and in parentheses, base 1 plus base 2. All right, so think of it sort of being like a triangle, except there's 2 bases. Add those 2 bases together to get 1, and then there you've got the triangle formula, sort of. Okay, so that is all of the formulas that you need to know for this lesson. All right, so let's look at a couple of examples. Probably not going to do the typical ones where they give you a shape, they give you the dimensions, and you have to multiply it out. We're going to do something a little bit different here. Find the height of the triangle with base 6 feet and area 27 feet squared. So, you know, I always like to draw pictures. They help me see what's going on. So I'm going to use a right triangle because honestly that's probably the easiest. I'm going to say that my base down here is 6, and I don't know the height, but I know that the area is 27. So what I would recommend, like all of these problems, you should begin with writing the formula. That way, that'll help you remember them, and you can recall them when you take a test, and they're not given to you. So for area of a triangle, I would go base times height divided by 2. You could do 1/2 base times height, whatever you prefer. So you now plug in the values that you know. So for area, I'm going to plug in 27. For base, I'm going to put in 6. Height, I don't know, and then that's over 2. So my first step in solving this, I could do it a couple of different ways. I'm going to go this route because I think you'll understand it better. I'm going to multiply both sides by 2. And that cancels out this denominator of 2 over here, and you get 6h on the right, 54 on the left. What? Yeah, you could use either formula. And then divide both sides by 6. Now be careful. So my answer is 9, but I got to label it. My height would be 9 what? Feet. It is not feet squared, it is feet, because you're just measuring a dimension. It is 9 feet. All right, if they've already got the area, then you're not going to answer in square units. You're finding just a distance. Questions about that? Now this one is, I decided to go ahead and do a circle one for you. It's area and it has a radius of 5 inches. So I'd write down my formula, pi times radius squared. I'm doing this one because I just want to reinforce about the squaring. So it's going to be 3.14, and you plug 5 in for the radius, 5 squared. Following PEMDAS, I must square the 5 first. So 3.14 times 25. That's why I'm doing this example, so that you do not forget. You got to square that first, and then at this point, 3.14 times 25, you get exactly 78.5. inches squared. So the final answer is 78.5 inches squared.